Wir
The deep ocean is beautiful. Its scale defies understanding. More than 95% of planet Earth's waters exist in near-perfect darkness, below the glimmering skin of the waves, in a place where no light can reach. By volume, this hidden place is Earth's largest habitat. Let's try something. Close your eyes. Picture in your mind every city you have ever walked, every great forest you have ever visited. Think how endless they seemed as you wandered through. Think of every mountain path you might have climbed and the view of all the valleys beyond. Think of your home country, the scale of it, the time it takes to commute, let alone cross it. All of these places together would not fill a corner of this abyss. If we turned Mount Everest upside down, its summit would still fall short of the ocean's deepest trench by 2 kilometers. But it is not empty space down here. Down in the fathomless deep, in the veils of blue, in the cavernous trenches, and among all the strange and shifting rocks that build its floor, there is life to be found. In every corner, there is life. The things that dwell down here may seem to you and I to play by strange and unfamiliar rules, and take on curious, perhaps otherworldly forms. But truthfully, it is a matter of perspective. A frog may appear just as alien as an anglerfish to a person who has never seen one. And within this busy world of brave new wonders, every one has a purpose, and weaves that great purpose into its own story. So please, settle in, breathe a little more slowly. Let the light thin. Imagine pressure folding over you. And sink. We begin with weight. A weight that presses from every side. And sound. The ocean, that ancient cathedral whose nave is darkness, whose stone is water, whose organ is the clicks, cracks, and threaded songs of uncounted species casting their vibrations through the dark. Sperm whales click and boom with the loudest biological sounds on Earth. Coral reefs crackle with the tiny snaps of shrimp and fish. And all of it carried further, faster, and truer than sound can ever travel through air. To be precise, sound moves over 4 times faster in water than in air, because water's tightly packed molecules transmit vibrations more efficiently than air's spread out molecules. In a way, the water is but the hide of a great drum whose skin is struck ceaselessly by the lives within it. The ocean is shaken into song by the beating of 1,000,000 lives. And here we hang at the threshold. Above us, the sunlit skin of tides. Below us, the night kingdom, indifferent to those tides. The ocean begins here, in the truth that most of this planet is not made for us at all. Let's take a look at what wonders we find. Let's begin, as these films rarely do, at the bottom for once. Here, at the far depths of the ocean, lies the abyssal plain, a vast, seemingly desolate expanse of flat seabed that stretches across more than half of Earth's surface. unfolding in depths between 3,000 and 6,000 meters beneath the waves. It is among the flattest, most uniform landscapes on our planet, with long slopes so subtle they may vary only a meter or two over kilometers, for there is no wind here. The currents are gentle, and all that falls from above has only to lean into the pull of gravity and settle. There's nowhere else quite like it, and it remains one of the least explored realms on Earth. No sunlight at all penetrates, and the pressure rises to hundreds of times what we feel on land. But in this seeming emptiness, faint richness accumulates. The sediment falls slowly through thousands of meters of water. The entire sea floor gathered from a fine drift of dead bits and pieces. You could think of it as the ocean's dandruff, but perhaps the more beautiful name is marine snow. It doesn't look like much, but that mud is miles deep in time. The dust of continents, the shells of plankton, the soft snow of all that has died above. In remote basins, this can settle at about 1 millimeter per 1,000 years. Leave it long enough and it builds hundreds of meters thick. In the oldest basins, more than 1.5 vertical kilometers of silt lie pressed into the sea floor, each layer a page in the ocean's book of time. So it's no wonder a host of animals have settled here, many of which have forsaken the ability to swim. We find organic detritus that drifts down. Foremost among them are the sea cucumbers. Just briefly, here's a quick word from our sponsor.
Ich verstehe es immer noch nicht. Wie hilft Clock.in dir jetzt, die Projektstunden abzurechnen?
Nochmal, mit der Clock.in-App erfassen meine Mitarbeiter Projektzeit.
A quick word from our sponsor. Thank you to Opera for sponsoring Natural World Facts. Opera is my sea cucumbers. Soft-bodied and slow-moving, they glide across the mud like living conveyor belts, swallowing sediment and sifting it for nourishment. What passes through their bodies emerges cleansed, the grains turned over and renewed. In some regions, the sea cucumbers make up the vast majority of visible life on the abyssal plain, processing the seafloor as earthworms do in soil. It is this unseen engine that keeps the deep alive. Among them prowl the giant isopods, cousins of the woodlouse or pillbug, but here grown to nearly 1/2 meter long. Like in a forest where fungi and insects decompose the fallen, here too this cleanup crew keeps the cycle of life turning. Nothing is wasted in the deep. Every flake and scrap of flesh is taken up by someone and recycled into the living weave of the abyss. Sometimes the plain receives a little more than drifting dust. A tree that once stood tall on land, or an old wooden ship, may be churned by storms into the open sea. As it sinks, it becomes what is known as a woodfall. Colonies of wood-boring clams and microbes make quick work of its fibers, releasing nourishment into the water. Around them, a small but thriving community gathers, feeding until the last sliver of timber dissolves into the plain. What makes this so remarkable is the fact that there are organisms and microbes here in the deep that rely almost entirely on wood. Wood that can only grow thousands of meters above and on land. And wood is no easy meal. It's built from lignocellulose, cellulose and hemicellulose fibers locked within a matrix of lignin that resists decay. To crack it, specialists enlist microbial partners that supply powerful enzymes, converting land-grown carbon into animal biomass on the abyssal floor. Across months to years, woodfalls undergo succession. Early colonists, amphipods, isopods, bacteria, give way to wood-boring bivalves and their associates. Later, chemosynthetic mats and specialist invertebrates dominate before the resource is exhausted. Community composition varies by region and depth, but again and again the pattern holds. A tree from a distant shore becomes an island of energy, stitching terrestrial productivity into the deep sea's food web. The hungers here are able to vanish an entire ship in under 100 years, typically leaving behind only the metals that could not be digested. Like these try-works, the metal pot used on whaling ships to melt fat from whale blubber. There are exceptions to this rule. For in March of 2022, the wreck of Ernest Shackleton's ship Endurance was found with all its wood intact, 107 years after it was lost in 1915. Situated 10,000 feet below the ocean surface in Antarctica, it appears suspended in time. This is because woodfalls here are rare, and animals in the Southern Ocean have not adapted to use wood as a food source. With the nearest landmass, Antarctica, being devoid of any trees, there's been no pressure to do so. It would be silly to rely on wood here. In addition, animals that are capable of breaking down wood are unable to migrate this far south. The sharp temperature gradient at the Antarctic polar front serves as a barrier to these animals. But despite hosting no fauna that is able to digest the wood itself, Endurance is still an oasis of life for deep-sea creatures that use it as a solid surface to attach to. The colonizers of Endurance are predominantly filter feeders, making use of specialized appendages to pull organic particles out of the ocean. Those same bits of dead animals we saw earlier. Sea lilies, a type of echinoderm closely related to starfish, use hair-like structures to adopt this way of life, living alongside sea squirts, which instead trap food by cycling water in and out through tube-like siphons. A brisingid sea star also decorated the helm, waving its arms in the water to catch debris. Wood is not the only feast to feed the deep. Greater still, and accessible to more than just those few who can digest wood, are the whale falls. The final descent of an ocean giant. When a whale dies, its body drifts downwards, a slow and silent collapse through the dark until at last it strikes the seabed. First come the scavengers, sharks, isopods, hagfish tearing the flesh. Then, as the skeleton remains, sulfur-loving microbes colonize the bones, feeding yet another succession of worms, mollusks, and crustaceans. An entire ecosystem, rising out of the silt from a single death, and lasting for decades, even centuries, as the carcass becomes an island of life. Torrents. Hydrogen sulfur A living fuzz coats the rock. It is formed of vast colonies of chemosynthetic microbes, stretching out in hair-like filaments. Unlike almost all life on Earth, they have no need of sunlight. Instead, they draw their energy from the vent's chemical torrents. Hydrogen sulfide, methane, iron, and transform them into sugars through a process called chemosynthesis. This quiet alchemy is the foundation of an entire community, sustained not by the sun above, but by the fire, water, and stone below. Wondrous are the creatures that have surrendered mouth and stomach entirely. The giant tube worms, Riftia pachyptila. They root themselves in the vents, their bodies sheathed in long white tubes that grow to 3 meters, or nearly 10 feet. It's hard to tell through a screen, but some of these worms stand so tall as to dwarf any human being that has ever lived. At their tips, a crown of crimson feathery plumes unfurls, rich with blood pigments that draw in the vent's chemical breath. Beneath, the body is pale and hollow, for these worms have neither mouth nor gut. Instead, within lies an organ called a trophosome, home to billions of the bacteria. The microbes feast on the sulfides drawn from the vents, and in return they feed their host. The worms cannot live without the microbes. Neither, for that matter, can its neighbor, the Pompeii worm. This builds fragile U-shaped tubes along the walls of black smokers, where the water temperature can soar above 80 degrees Celsius. Yet it survives because of these microbes. Along its back, it grows a fleece of these bacteria, fed and encouraged by the worm's own mucus secretions. In return, they insulate the worm from the extreme heat, detoxify the chemicals, and provide nourishment. To us, it seems impossible, but here, it is simply another niche filled. Creatures of the deep are rather good at making the most of any habitat or resource. Deep-sea skates, relatives of rays, use the outskirts of vents or hot seeps at seamounts to incubate their eggs among the warm rocks. It's an approach shared by some octopuses too. At Dorado Outcrop, off the coast of Costa Rica, hundreds of deep-sea octopuses gather. The females settle in crevices warmed by hydrothermal seepage, curling around their eggs in patient vigil. Here, they brood for years, waiting for their young to hatch, and do not seem to leave their eggs unattended, not even to feed. The warm waters from the hydrothermal vents in the area likely plays a role in increasing the mother's metabolic rates, which speeds up embryonic development compared to typical deep-sea abyssal octopods. Even so, the eggs of some octopus gardens take up to 4 years to hatch, theirs being the longest incubation time in the entire animal kingdom. Beyond the vents and seeps, on the flanks of other seamounts, lie more sanctuaries. There are great coral gardens spread across the slopes, thriving not in sunlight, but from currents bearing nutrients and prey from the deep. Among them rise vast sponge grounds, their slow-growing bodies filtering the water, providing habitat and shelter for countless creatures. But not every part of the ocean is blessed with some kind of sanctuary. Far above the vents and the seamounts, there are vast regions with no anchor, no rock, and no refuge. What of the inhabitants of this place? What of those who spread their wings and brave the void in place of putting down roots? What of those who do not visit the abyssal plains and stay where there is only the endless blue or yawning black, fading into haze? By any means necessary, for they cannot wedge themselves into. There are 3 subdivisions we can attribute to the adrift. Those who wish to be seen, but not as they are, like the swordtail squid, which mimic the appearance of a nearly nutritionless, stinging siphonophore, in the hopes it makes it seem unpalatable. There are those who wish to be seen, but only in part, like the famous anglerfish, relying on its lure to entice prey. And there are those who do not wish to be seen at all. This is by far the most popular choice, so much so that everywhere you look in the pelagic void, you will find some new and interesting variation in their way of making themselves disappear. If you're able to find them in the first place, that is. They might be bright silver, so as to reflect as much light as possible, and thus blend in with that light. They might be dark red and vanish completely, for red wavelengths of light are filtered out at shallow depths.
Now, remember earlier that I said agents can call agents? Well, that isn't just a one-off.
They might have dark upper surfaces and bright bellies to blend their silhouette from every angle. Or they might be simply invisible, a luxury option not afforded to animals outside the ocean world, for it is only here in this exclusive club that the absence of damaging UV rays from the sun can release these animals from their need for protective pigmentation. Here be nature's true spectres. From the void drifts a near invisible wanderer. The telescope octopus, Amphitretus pelagicus. Gelatinous and almost colorless, with 8 equal arms, it spends its life suspended in open water across the Indo-Pacific. It is the only octopus with tubular eyes, elongated cylinders that protrude like tiny periscopes to gather the faintest scatter of light in the midwater dark. It's one of the only truly pelagic, that is, open water, octopus species, and recorded from about 150 to 2,000 meters down. The vast majority of octopuses are demersal, meaning they live on or near the ocean floor, and typically in dens they construct from rocks and other seafloor structures. Not so with the telescope octopus. Transparency hides its outline, and those tubular eyes widen its view, helping it watch for the bioluminescent glow of predators, prey, and passers-by in 3 dimensions of night. It is perfectly suited to remain suspended here forever. As with anywhere in nature, where there is space to be used, animals will use it. In a space as large as this great void, many of these pioneers have spread their forms to become giants. And in a space without any shelter, the giants become the shelter. The folded cloaks of jellyfish, becoming the tender arms of guardians, shepherding life through the watery plain. Jellyfish lack a central brain. Instead, they run on diffuse nerve nets that sense touch, chemicals, and light, with neurons coordinating the bell's swimming strokes. Around the bell margin sit sensory hubs, and in some groups, nerve rings that help time each contraction and gather the world's signals. In this way, a web of nerves choreographs a body made of 98% water and 2% gelatinous mesoglia, all finely attuned to minute changes and stimuli that you or I will never feel. Yet these physically simple life forms are far more than just sufficient to survive the dark sea. Just as we only really know the land, and the mud dwellers only know the silt, here in the void, the dark and the current and its echo of the uncounted sounds and living light are all that these drifters will likely ever know. And the lights of an ROV are all they may ever know of us. That is their world, as it is the largest part of ours. And it is not to be overlooked. The ocean does not begin at the shore. It does not end at the horizon. It's not a surface to be crossed, nor a backdrop for weather. It begins in the clouds, in the rain, in the rivers that run down to meet it. It begins wherever salt is carried and wherever tide is felt. We think of the sea as flat and blue and empty. But this is its greatest illusion. For the ocean is not at its heart an expanse of waves. It is an interior, the hollow of the world that drops away beneath us. It is a home, and it is beautiful.